Okay. Now, let's move into chapter 5.1, okay? What is the sum of all the probabilities of all outcomes in a probability distribution? Well, if you remember, the probabilities are P of X. So they all have to add up to 1 for it to be a probability distribution, if you recall. The next question says, the time it takes to study for a stats test is what kind of variable? Well, if you remember, okay, we have, if you're studying, you can look at the hours, the minutes, and the seconds here that you've done this. And so if you remember, stuff with really tiny increments in between it was considered a continuous time measurement. Okay? Alright. Now, let's move on to number 3. Number 3 is asking us, one of the requirements for the probability distribution is what? Which one of these? Well, if you remember, your P of X always has to be in between 0 and 1. It can't be a negative number, okay, because it can't be negative. That kills B. It can't be greater than 1 because they all have to add up to be equal to 1. And it can't be, you can't just put greater than 0 because that can mean something bigger than 1. So it's got to be C. Make sure you know that. Now, this next one says, if the P of X equals X over 7 for X is 1, 2, 3, 1, 2, 4, which is the correct representation of the distribution? Well, first of all, what we can do is just sit here, and even if they didn't tell us anything, they said which one works. We need to add up all these, okay? And if I add these up like that, guess what? That's going to be bigger than 1, so go to the next one, add these up. Well, guess what? That doesn't equal 1. So here, add these up. Wait, ooh, look at this. These are all bigger than 1, so no. This is going to be greater than 1 again. No. But last but not least, if I were to add these up, and plus there's the correct way to set this up because I have 1, 2, and 4 there, and my thing can be 1 over 7, 2 over 7, and 4 over 7, okay? And these do add up to equal 1, so bingo, D is the answer. Now, look at the next problem. So number 5, given the following distribution, state whether it represents a probability distribution or not. What is to justify our answer? Well, we looked earlier with the multiple choice questions of what do we have to have in order for this to be one of those distributions. Well, the first thing was you had to have 0 in between P of X and 1. So P of X had to be in between, sorry, I said that wrong. P of X had to be in between 0 and 1. Okay, let's look at these. 1/4, 1/2, 3/4. None of those are bigger than 1, so that has been met. Let's look at 2. 2 says that these have to add up to equal 1. Well, guess what? They don't. So, doesn't happen. The sum of P of X has to equal 1. It doesn't in this case because 1/4 plus 1/2 plus 3/4 is greater than 1. So, it's a no. Big ol' no. And I justified my answer by showing that those added up to be greater than 1. Okay. Let's look at this problem here. It says use probability distribution given a 1. Let's find the mean and then the variance. Okay. So to find the mean is this formula that has you multiply your x's by your P of x's. So we use mu to stand for the mean. This is going to be 1 times 1 point, oops, I put 1.5. 1 times 0.15 plus 2 times 0.60 plus 3 times 0.15 plus 4 times 0.10. Punch that into a calculator and you should end up with 2.2. Now, the next one's saying using the probability distribution given above, the variance is, and it wants us to find it. But here's the deal. I'm going to get an answer here and I'm going to have to round, okay? And it's kind of weird because one of the later questions, which we'll see, section number 4 in this section, asked a question about rounding rules, which you have to know before you can even do this problem, or else you're like, my answer's not up there. So, the variance is a little bit harder. I'm probably going to have to scroll down to do it, but I'm going to write the formula here. Variance is like your little sigma squared, is the sum, that's what that big weird looking E is, of x squared times P of x So it's kind of like what we were doing here, except I'm going to go in and go boop, 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 square all them, okay? And then I'm going to minus the mu squared. So it's really not too bad. You just got to know the formula, which I know that your teacher's going to give you on the test anyway. So I have my numbers. I have it written down. So I'm going to go down here and write out what the formula should look like for this one. Okay, so I'm doing number 2. Down here, I know this is confusing looking. So this would be like 1 squared times 0.15 plus 2 squared times 0.60 plus 3 squared times 0.15 plus 4 squared times 0.10. Do all that, and then I'm going to minus 2.2 squared. Okay? All this gives me 5.5. So 5.5 minus 2.2 squared gives me 0.66, but again, I talked about the rounding. You got to round that up to 0.7, which is D, which is my answer. Now, the next one is asking us to find the standard deviation. So that's where I take this whole thing I just did and take the square root of it. So I'm just taking the square root of 0.7, okay? When I punch that into a calculator, I get 0.83. Now, if I got 0.83, again, do I see 0.83 here now? Rounding, which in this case I would round down to 0.8. So it's C. And do make sure you know how to do this. I mean, it's not hard work. Any kind of calculator would do this for you. Pretty simple. Okay, but you have to know when to use the formula for what type of problem here. That's what stats is all about. So the next one, number 4, here it is. It says, whenever a probability distribution is used to find the mean, the variance, and the standard deviation, the rounding rules are round to 1 or more decimal place, reduce to fraction. Both A and B, there are no rules. There are no rules. Okay, no, that's not it. It's both A and B. Because we have to round, which we did earlier. And if we had a fraction, well, we have to reduce it, okay? You don't want to put 2 fourths on there as your answer. Alright. This next one says here, assume P of x equals x over 16 for x equals 1, 3, 5, and 7. And they tell you all this stuff here. Write the distribution for the formula. Determine whether it represents a probability distribution or not. Find the mean, standard deviation, variance, and answer those questions. Okay. Whew, a lot of work for this one. Alrighty, so I need to make my little table. So my table was x, P of x, just like this. My x's are 1, 3, 5, and 7, and my P of x is respectively, as we saw up there, was x over 16, so it should be 1 over 16, 3 over 16, 5 over 16, and 7 over 16. Now, I need to figure out, are all of these in between 0 and 1? Yes. Does the sum of all of these equal 1? And if I take a calculator and I sit here and add it up, yes. So this actually is a probability distribution. If you're not sure, try on your own. Now from here, it's asking us to find the mean, variance, and standard deviation. So we're going to do that. Okay, so let's go ahead and figure out our mu, our variance, and standard deviation. So to write this out, I'm going to need a lot of space for this, is I'm going to come down here and I'm going to keep going. So my mu is going to be, like we saw earlier, 1 times 1 over 16 plus 2 times, oh, not 2, sorry, 3. Don't know where the 2 came from. 3 times 3 over 16, okay, plus 5 times 5 over 16, plus 7 times 7 over 16. Now, punch all this into the calculator, and you should end up with 5.25 for your mu, okay? Now, if my mu is 5.25, I do have to round this to 5.3, okay. Now, the next one is to find the variance. Well, remember the variance is the same thing that we just did, pretty much, except it's 1 squared times 1 over 16, plus 3 squared times 3 over 16, plus 5 squared, 5 over 16, plus 7 squared times 7 over 16, and all this, big old brackets, minus 5.3 squared. Now, this in my calculator ended up giving me 3.4. It actually gave me a longer decimal, but I rounded it to 3.4, okay? That gave me my sigma squared. Now, to figure out my sigma, I take the square root of 3.4, and I end up with 1.8 whenever I've gone ahead and rounded it. Now, that's how you figure out your mean, variance, and standard deviation for this problem. You notice at the top they had some questions that we have to go back and answer. Okay, so we did this hard, long, difficult part. Let's scroll on back to the top and answer these questions. Alright, first one says, find the probability of time it takes to finish the work in 3 hours. And then they show you that P is x equals 3. So you go to your chart, which we have right down here. What is the probability of that? Well, 3 out of 16, that's it. Okay? Next one says, find the probability of time it takes to finish the workloads in at least 5 hours. P is equal to 5 or greater than. So I'm looking at those two. How do I find that out? Add them up. So I'm going to have 5, I'm running out of space to write. 5 out of 16 plus 7 out of 16, which gives me an answer of 13 out of 16 for 2. Let's do 3. 3 is saying, find the probability of time it takes to finish the work in at most 3 hours, so less than or equal to 3. Well, it's going to be those two. So I have 1 out of 16 plus 3 out of 16, which gives me 4 out of 16, which reduces down to 1/4. So I know it's a pretty messy problem here, but that's what we need to do to find those answers. We'll stop this and continue on to 5-3.